everybody, I'm coming back with another progress video. This time I added a road system to my plugin. So this road system supports intersection. You can override any mesh between 2 points. So for example, you can add bridges with this. You can also control the flow of the curve and mesh. This is not just for roads, you can use that also for things like rivers, walls, and many other things. This also has a LOD system. So basically, as you get close to one section of the road, the LOD level of that mesh can be changed. In this video, I'm going to explain how you can use this road system. By the way, at the time of the recording this video, this still has some small bugs which I will solve them later. Also, there are some other things which I need to add later, like train deformation tool based on this curve, roadside mesh, and collision. Also, I want to thank all of my Patreon for their support, and now let's start. To understand how you can create roads, you should understand how curve system works, because the road system is based on that. I rewrote another curve system from scratch, so this curve system is not the same as the Godot curve system. My curve system is based on the Bézier curve. You can find the formula for the Bézier curve on Wikipedia. Basically, in Bézier curve, we have 2 points in a space, which we want to draw a line between these 2 points. We don't want a straight line, we want a curved line between these 2 points. So what we are going now is to add 2 control points. Basically, with these control points, you can control the Bézier curve. There is no magic in this thing. The formula for the Bézier curve based on the position of the points and control points are in Wikipedia. You can read about them. After defining the curve with points and its control point, we can create a mesh based on that. I am not going to explain how we create mesh based on this curve, but the important thing here is this. Here we generate a different mesh and mesh instance for each connection between 2 points. The curve mesh which you can see here is generated in runtime, and each of them has a unique mesh. This is an important thing to know. Basically, this means if, for example, you create a road with 2 points with length of 100 km, then you have created a single mesh with a lot of vertices. And you should avoid doing that. You should break the mesh after a while. So when the camera is not looking at the road mesh, it will be called. Also, we can apply different level of LOD to each of this mesh. Even we can remove the mesh after a certain distance to the camera. So up to this point, we know we generate a different mesh for each connection of our road system. Now what about intersection mesh? If we also have an intersection mesh, we generate for each point one intersection mesh with the same number of output. If you are confused, don't worry, I will show everything later in this video. So now let's see how the LOD system works in our curve system. Based on the distance of each curve point to the camera, we give each point an LOD number. Points which are closest to the camera have the LOD 0, and as we go further away from the camera, the LOD number will increase. Also, we define what distance the LOD level change. Now we don't check the distance of each point to the camera to calculate the LOD level. Instead, we use a much faster system which is called Octree. I already created a video about Octree and MOctMesh. I will put the link of that video in the video description. Basically, what we do here is this. We send each point of our curve with its position and its ID into the Octree. Then Octree at each loop will send us which point with which LOD has been changed. After receiving the LOD level of each point of our curve, we need to calculate the LOD level of the connection between these 2 points. Here basically we set the LOD level of the connection between 2 points to the smallest LOD of its points. Well, now let's see in practice how all of this works. Before creating any curve, we need to create an Octree. As I said before, curve LOD is determined by this Octree. To create an Octree, first create a script, then change the extend type to MOctree. After that, in init function, just call enable as curve updater. You can also activate that as MOctMesh updater. MOctMesh is another node which works on top of Octree. I have created a video about that. You can see the link of that video in the video description. After that, we should define the LOD setting for this Octree. I define the LOD setting like this. This means every point which has the distance less than 10 meter is LOD 0, between 10 to 20 meter is LOD 1, and so on. For this video, I will put this setting, but you may try some different things for this. After that, activate the tool mode for this, so this will work also in editor. Then add this script as an autoload in Godot. Okay, just restart Godot and you are good to go. Okay, now as I restart Godot, our Octree is active and the curve system automatically recognizes that. And we don't need to do anything else, but each time you change Octree LOD setting, you need to restart Godot again. To add a curve, you need to add a node which is called mPath. mPath node has some limitation. One of the important limitation is that you cannot move that. If you try to move that, it will return to the same place. Now just add a curve resource for this node. Another important thing about this curve is that please don't use this resource in two different nodes. Basically, whatever you are making with this curve system, even a large word, you need only one central path and curve for that. And that will handle everything for you. Okay, now let's see how this curve system works. First of all, in editor, we have two different modes for curve. Edit mode and create mode. For now, as we want to add a curve point, I change the mode to create mode. You can also toggle between these two modes with tilde key on your keyboard. Okay, now click on the screen and this will create some curve point for you. As you remember, I said the Bézier curve has a main point and some control point. To change the control point of any point, just hold Shift and click and drag. Okay, as you can see, by changing the control point, we can control our curve. Now there are a couple of options for curve handle or control point. There is a checkbox which is called M, which if you disable that, this will disable mirroring. As you can see, if I disable mirroring, each curve handle can be moved independent from each other. There is another option which is for mirroring lens. If you deactivate that, this time handles are mirrored, but the lens is not mirrored. So the next option is called a snap. If you have a train in your scene, this will snap each point to the surface of the train. And if you don't have any train in the scene, this will snap each point to the y0 plane. There are other options for moving the curve points. If I grab one point and I move that a little bit, then I press X, this will constrain the movement of that point on X axis. The same rule applies if I press Y or Z. Now if I press Shift Y, this will constrain the movement of the point in Y plane. The same rule applies for other axes. If you worked with Blender, these are the same hotkeys. Next thing is the collapse button. If you press that, this will reset the point handles. This will be useful for things like intersection. You will see that later. There are 4 buttons on top which I explain about each of them. The most right button is the remove button. If I press that, this will remove the current active point. You can recognize the active point by its color. You can also remove a point by pressing the backspace button. Now if I press Ctrl Z, this will undo this step. Now let's see how we can create an intersection. To connect the newly created point to any of these points, you need to activate the point that you want to connect to. So after activating this point, I will add another point. You can see the newly added point will be created here and connected to the last activated point. The maximum number of the connection for each point is 4 by default. You can change this number by modifying the macro in C++ code and recompile this GD extension library. But if you do that, that will take more memory. And as a point with 4 connection is mostly enough, I set that to 4. And now this is the important concept that you should understand. And that is how to control the flow of the curve. Let me show you what I mean. So here I click on the first point to make that as an active point. After that, hold Ctrl and click on the connected point. Here we have one active point and one selected point. And now if I click on the T button, this will change the flow of the curve at the active point side. You can do the same thing by pressing the T key on your keyboard. Now let me show you how exactly this thing works. If I disable handle mirroring, you can see the connection will be controlled by one of these handles. And now if I toggle this connection, the connection will be controlled by another handles. Okay, now let's see how we can connect 2 points together. Just select 2 points that you want to connect together and click on the C button. You can also use the C key on your keyboard. You can also disconnect 2 points by selecting them and click on the yellow D button or X key on your keyboard. Now there are more options to this. If you click the mouse right button, other options also appear. Here we have the tilt and the scale of the point. This option does not change anything at this point. You will understand them when I make some mesh with this. The depth option will activate the depth test for the debug curve line, and this is not really important. The XY lock, this will lock handles in XY plane. This is really useful for creating roads as we don't want to change the handle in Y axis. And finally, we have 3 more options here. To understand these buttons, I need to explain this. So in my curve system, every curve point has a unique ID. When you select and move one of these points, the ID of that point will appear in the bottom left corner. As an example, this point has the ID of 4 and this point has the ID of 2. One important thing about these IDs is that the direction of the generated mesh based on these curves is always from the point with the smaller ID to the bigger ID. This usually does not matter in case like the road, but if you are making a river, this will matter to you as river has a certain direction. So here if I select 2 points and I swap them, this will swap the ID between these 2 points. And yeah, this is not supposed to happen. This is a bug which I will fix later. By the way, now these 2 points have been swapped. You don't need to swap each 2 point by yourself. There are much easier methods to control the flow of the river, which I will show you later. Okay, I hope you understand how the curve system works. If you have any question about this, write in the comment section. Now let's talk about how to create a road mesh based on this curve system. The most important thing about creating road mesh is to have a good mesh. Your mesh should have some features, otherwise this will not work. First and the most important thing is that your mesh vertices should start from the x0 position and they should continue in the positive x direction. After that, your mesh should have some loop cuts in x direction, so it will have enough geometry to create a curve. And all of these loop cuts should be perpendicular to the x-axis. The algorithm that I wrote makes the curve calculation for each group of these loop cuts for better performance. And finally, your mesh cannot have multiple surfaces. By multiple surfaces, I mean you cannot assign multiple material for different part of your mesh. Your mesh should have a single material. Also, you should know this mesh is just a blueprint for the curve mesh to create the real mesh in runtime. Basically, curve mesh will create a separate mesh for each connection by analyzing this mesh. Another thing that you should pay attention to is when I duplicate this mesh and I put that after this, the mesh must repeat itself seamlessly. Here I have created the same mesh with less vertices for LOD1. For this video, I have created this mesh with 2 levels of detail, but it is better to also have more simpler mesh. Okay, now I have created another mesh with different type of line on it. Also, this one has 2 LOD. I also created another road mesh with some concrete beside that. Basically, you can create different type of road, one with the cross line, one with the bridge, and so on. The important thing here is that all of these road meshes should connect to each other and they should repeat seamlessly. One other thing before exporting this mesh is that if you triangulate your mesh before exporting that, it will be better. Well, now let's import our mesh. First, I set the save path for my road mesh. By the way, if you choose a good naming convention for your meshes, it will make things easier. Now here, as you want to import your mesh, definitely disable Godot automatic LOD system. Okay, I have my road meshes in this folder. Well, now before I start to create the curve mesh, I briefly explain how I made my road shader material. Here I have these two types of the road asphalt texture, which I mix them later, you will see. I also have another separate texture for road lines and concrete texture. Remember, as I told you before, we cannot have multiple material for our mesh. We need to create only one single material for all roads. Okay, now let's see how I use these together. I won't read from the asphalt texture with mesh UV coordinate. I am using the vert position of each vertex. What I mean by that? Imagine we have this plane mesh in 3D space. Each vertex in this plane mesh has this UV coordinate. For every other place in this plane mesh, graphic pipeline automatically interpolate these UV coordinates. Now for this plane, each vertex position is this. Here, instead of using UV coordinate, I will use the vert position in X and Z plane. To calculate the vert position, I will use model matrix, and then I set the vert position X, Z value in asphalt UV. Please note here, asphalt UV is a vector 2D, and it is a variant that means the value of this vector will be interpolated and can be used in fragment function. Now I read from the first asphalt texture by asphalt UV. You can see by using the vert position that will give me a seamless texture on my road. I also added this noise texture and I read from that by asphalt UV. Then I will mix two asphalt texture based on this noise texture. After adding and mix normal map and roughness, I achieve this. Now it is time to add road lines. This is my road line texture. You can see I adjust each road mesh UV on different part of this texture. So I will read from this road line texture and I will add that on top of my previous texture based on the alpha channel of the line texture. This will remove asphalt texture where the road texture is and will keep the asphalt texture where the road line does not exist. Please add this material on your mesh so it will be added to your road automatically when you create a curve mesh. Well, now it is time to add our curve mesh to the scene. As the child of your M-path node, add a curve mesh node. Please note the curve mesh node must be the child of the path node. Now open the mesh section of the curve mesh node, increase the mesh count number, and after that add a mesh LOD resource to this. Mesh LOD is basically a resource which can receive a group of the meshes with different LOD. Here I have created two different levels of detail mesh for our main road. But let me make clear how the LOD level work here. As you remember, I set up my LOD level in Octree like this. This means every point which has the distance of less than 10 meter are LOD 0 and between 10 to 20 meter are LOD 1 and so on. Now here for LOD 0, I can put this mesh. One thing that you should note here is that if I put the same mesh in LOD 1 section, when the connection LOD change from LOD 0 to 1, no new mesh will be generated and everything stay as same. Then for example, I can set the next low poly mesh in LOD 2. So when the LOD change from 1 to 2, a new more low poly mesh will be generated. This is useful if you want to use one central Octree for everything. I don't need this and I have set this mesh in LOD 0 section and this mesh in LOD 1 section. Now what happens if my connection LOD is 5 for example? You can see we don't have any mesh for the fifth LOD slide. In that case, the curve mesh automatically grabs the last active mesh, which is LOD 1. If you increase the LOD count to 3 and you leave the LOD 2 slot empty, this time if the connection LOD is 5, it will grab the empty LOD level and it will remove the road mesh. This is not too complicated. If you work with this system, you will understand what I mean. Well, now I will add other road meshes here. So I added them all, but one thing you should note here is that the road mesh by default select the first mesh unless you override that. After adding these, you need to click on the restart button, so that will create the curve mesh. By the way, at the time of the recording of this video, there is a bug in the curve mesh, but if you restart Godot, everything will work properly. Well, I restart Godot and this is my curve mesh. I can add new point to the curve and the curve mesh will adjust itself. One thing you should note, you should keep mirror checkbox active if you want a continuous mesh. Look what happens if I disable mirroring. With this type of the mesh, you can also somehow create intersections. You can see here I have an intersection. I have a little z fighting, but if I move one of the point in y-axis direction, there is no more z fighting. Also, if I activate the wireframe mode, you can also see how mesh LOD level change. Now let's see how we can override the road mesh at some part of our road. Just click on one point to make that active. After that, hold Ctrl and click on another point to also select that point. You can see the connection between these two points is changed to green. This means this connection is selected. After that, in MPath Inspector, there is a section which is written Override. Click on that and select your curve mesh. By selecting that, you can see a new panel will appear that has two parts. One is for connection and one for intersection. Now down here, by selecting a different mesh, you can change the curve mesh for the selected connection. You can also remove the curve mesh. Well, now let's see how we can add intersections. First and the most important thing is how we should create our intersection mesh. To tell you how that works, first let me show you how intersection mesh is set up. This point curve has three connections, and this is my intersection mesh. The origin of the intersection mesh is at the center of this mesh. Curve mesh first put the origin of the intersection mesh at the same position of the curve point. Then it rotates that mesh to approximately match these three connections. And at last it will modify the vertices of this mesh so it will match the curve mesh and there will be no gap between this mesh and the original road mesh. Here I am in Blender and this is my intersection mesh. I have two intersection mesh, one has 3 output and one has 4 output. The important thing is that each of the output of the intersection mesh should connect to the main road mesh seamlessly. Now let's see how we can add this intersection in Godot. Open intersection tab in mCurve mesh node and increase the intersection count. Then add an intersection resource. Intersection resource has two parameters which you need to set. First one is the mesh LOD which contain the intersection mesh with different level of detail. And the next one is the sockets. Each socket is a transform 3D which shows where the output of the intersection mesh is. Or in another word, where this intersection mesh should be connected to the main mesh. This intersection has 3 output, so I set the number of the socket to 3. It is difficult to set the transform manually, so I made a small tool which can help you with this. As you select your curve mesh, just active modify checkbox. After you activate that, you are in the socket modify mode. Then the same intersection mesh will appear in the center of the world. Also in modify mode, your Godot editor is locked and you cannot select any other node. Here in top section, we have two options. With the first one, we can select different intersections. And the second one, we can select different sockets. For now, socket 0 is selected. Well, just move the socket 0 to one of the mesh outputs. Now look how this socket is positioned. The x-axis of this socket is exactly at the direction of the output, and the z-axis of that is parallel to the vertices at the connection point. This must be accurate, otherwise there will be a gap at the connection point of intersection mesh. Here, as I created the intersection mesh, I set all of the output vertices at 1.5 meter distance to the center. Putting these vertices at this number in Blender helped me here to accurately set the socket here. I just set other output sockets, and please note if you rotate that sockets and it will not rotate, just activate local space. Now here I have the intersections, but you can see I have a really distorted mesh. The reason for that is that the intersection mesh works best if the curve match approximately their output sockets. First, I collapse the handle of this point. and then I rotate the road so it gets less distorted. Curve mesh for intersection usually search the intersection resource and select the first intersection with the same number of the output. You can overwrite this or even remove this. But at the time of the recording this video, overwriting intersection has some bug, but I will fix that later. One other thing that I need to cover here is the tilt and scale for each point. You can see if I change the tilt or scale, this will rotate or scale the road mesh. The hotkey for this is K and E on your keyboard. Now let's see how we can control the flow of the mesh. Usually the flow of the mesh does not matter in things like roads, but in things like rivers it matters, as the water current in the river has a certain direction. The mesh flow in the curve is from the curve point with a smaller ID to the bigger one. You don't need to change all of these IDs by yourself. I made some tool for that. As an example, I want to make this curve point the source of the river. Basically, I want the current of the water to be always away from this point. So as this point is active, just click on sort. And here you can see the last connection is not okay. This is some small bug, just click on the sort another time and everything will be okay. You can make any of these points as the source of the river. Now imagine we have multiple rivers which merge at some point. Just click on the last merge river point and click on sort rivers. And we are done. Easy like that. Well guys, this was the road system. I worked on this for a long time and finally I can publish some part of it. I am really happy about that. Also, I want to thank all of my Patreon again. If you like my work, consider supporting me on Patreon. Thank you for watching. Until the next video, have a good time.